Okay, so here we have a mock set 4 paper, paper 2, so we're talking about a calculator paper, and I'm going to attach it to the comments so that if you want to download it, print and do, and then as I'm going to show you how to complete this test. Okay. So first questions, sorry this is a strange setup here. So divide 7,560 in the ratio 4:5. Now this is sharing ratios. So what you first need to do is figure out how many ratio parts we have altogether. So you've got 4 and 5. So you're going to add them together. I use something called Addem. So that's where we add the ratios. It doesn't always work, but in this kind of straightforward one it does. So we add the ratios, then the divide. So then we do 7,560 divide by 9, because that tells you how much one ratio is worth. Okay, and let's just get the calculator. So 7,560 divide by 9, 840. So each one is worth 840. Doesn't give any units. And then multiply. So then we've got the ratio 4:5, and then we would times both of those by 840. Because if one is worth 840, 4 is going to be worth 4 times that. So that should be 3,360. And then times the other one by 5, 4,200. You can also double check it by adding these two together, and if you did add those two together, you should get back to 7,560, and I do. Always check it, you've got the calculator there. It should always be in the correct order as well. They've given you the 4:5, so you must put it that way around. Okay, so that's question 1. Okay, question 2, we've got a Venn diagram. So here is a Venn diagram. List the members of X. Members is just what is inside of the members, what is retained within X. Now X is this whole amount here. It's the 1, the 5, and the 1, 5, 15, and the 3. Because even though it's in Y as well, it's still in the remit of X. So you're listing. So I'm just going to list them all together. I'm doing it in numerical order. I don't think it really matters, but I always do. So there's 4 numbers there, and there's 4 numbers I've listed. So X and Y basically means this sort of arch here, it looks a bit like an N. I think that's and. So basically the things are in both of them. And. Think of the word and. It's got to be both. And both of them, X and Y, is 3. It's the only one that fits in both X and Y. Now when it says X, U, Z, well it's not really U, but this is union, X union Z. If you think of a union being either or, think of like like European Union, it's a union of both. So it's both of them put together, really, either that or that. You then have to list all of the X's and all of the Z's. So 1, 5. I didn't do that in numerical there, but it doesn't matter as long as you've got all the numbers down. Okay, so my 2Z numbers 9 and 21, and then the 4 numbers that I had for X, or Z. So really they're just testing the symbol, really, you understand what that means. That's at both of them, and that's either or. Okay, a number is chosen at random from this symbol here means the set. So from the set, and you can see it here, from the set, find the probability that the number Y, so numbers chosen random out of here. So how many numbers have we in total? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers in total. So out of 11, how many, find the probability that this number picked is in Y or Z. So how many are in Y or Z? 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of 11 are within Y or Z. So that is a probability. You leave it like that. You can keep probabilities, can be kept in fractions, decimals, percentages, but just whatever's easiest. So there are 8 numbers that are in Y or Z, and there are 11 numbers in total. So it's that 8 out of 11. Just double checking there's none I've missed there. Okay, so that is the Venn diagrams. Question number 2. Mostly on that they're testing your knowledge of the symbols really, and it's just listing. So ABC is a right angle triangle. You see you've got a right angle here, and you've got 2 side lengths, and it's asking you for this length BC. Now that means that you are just looking at lengths. We don't need to concern ourselves with trigonometry at this stage. This is just going to be Pythagoras, which is a squared plus b squared equals c squared being the important hypotenuse. So we've got, if we know that 6.7 squared, we'll call this a and this b, add something squared, b squared, equals 16 squared. We can rearrange this so that b squared is equal to 16 squared minus 6.7 squared. I've got the difference between the two. Okay, and I'm just going to use my calculator and literally plug that in. So 16 squared minus 6.7 squared. You can memorise it when you're looking for the shorter side if you want to. Or you can just rearrange it when you do it. Remember, if you get to this point, you think, oh, b equals 211, you might notice that that looks completely wrong. That's because it's b squared is 211. So you just do the square root of that. You can do it all in one go if you want to. And you should get an answer of, so b equals 14.52962. Let's just stop there. And it says to 1 decimal place, so I'd round it. There's 1 number after the decimal, so I'd stop there, and the 5 is going to stay the same because 2 is under 5. So 14.5. Okay, if you wanted to do that all in one go from the b squared option, so if b squared equals, I'm just going to do this as a side thing for you. You can, to find b, just do a square root and just do it all in your calculator, all in one go, a little bit like that. I can't show you the calculator on this, but that's what it should look like. If you just press equals, you get the answer at the end, rather than finding the answer and then square rooting it. Okay. All right, so next question. So let's go to the next question here. So you've got here a number times 10 to the power 5, and it's asking you to do it in an ordinary number. So here it is already in standard form. If you'd forgotten that, you could look down here. It talks about standard form. The whole question is about standard form. And standard form is where there is a number between 1 and 10, or less than 10, greater than 1. And you have 10 times 10 to the power of something, depending on if you are timesing it by a bigger number or timesing it by a smaller number with negatives. So what we need to do here, if you're timesing it by 10 to the power 5, if you think of 10 to the power 5 as actually 10 times itself 5 times. Okay, it's a little bit like that. That's actually what that is. Okay, so you're going to make this bigger. So, and you're making it bigger in powers of 10. So you'll be moving this decimal in this direction, however many tens you've got to times it by. And so I like to put some zeros in here. Just put as many as you like, and then count. So you'll count the spaces. You know, timesing it by 10 will get you there. Times it by 100,000, and then 10,000. So we've moved it 1, 2, 3, 4 spaces. Actually going to move it 5 because we actually times it by 5 tens. So the answer. So once you've got that answer. Once you know where your decimal is, it's after 3 of the zeros. You would then just pop your answer in down here. Make sure it is clear where your decimal is, and then you can just do a little thing. Okay, so you're making it bigger by timesing it by 10, 5 times really. 1, 2, 3, 4, 5. Yeah, just double checking that number. All right, now if we're writing something in standard form, the number has to be between 1, it has to be greater than 1, less than 10. So to make that the case for here, you need to have the decimal after the 6. So the number itself is 6. Now, because it's a number less than 6, you're actually timesing it by negative, because you're moving the decimal backwards, this way, 1, 2 spaces. So you'll be timesing it by, not 10 to the power of 2, but 10 to the power of negative 2, because 10 to the power of negative 2 is the same as 1 over 10 squared. So that makes it, if you can see that, it's a fraction, it's a number smaller than 1. So it's going to make this smaller, because you can't, it's equivalent at the end of the day. You're actually just giving it equivalent number. And so the answer will be 6 times 10 to the minus 2. Okay, 4.62 times 10 to the power 8 tins of beans were sold last year. These tins of beans cost a total of 300.3 million. Work out the average cost per tin of beans. Okay, so we've got the amount of tins and we've got the cost. Okay, so what we'll do, we'll have the cost and we'll divide it by the amount of tins, and that should give us the value, the cost, per tin of beans. So the cost is 300.3 million. So if you think of million, I always think of 300 million, 6 zeros after the million part. So 1, 2, 3, 4, 5, 6, because it's that sort of 300 million. So if we have the dash there, it's another 6 numbers. Okay, I'm doing it as an ordinary number for now. Divided by, so that's the amount that it cost, divided by the amount of beans. And we could always just write it out in real terms, really. So if I look at how many, I'm going to have to move this 8 spaces. So let's just have a look. 1, 2, 3, 4, 5, 6, 7. And then I need 1 more here. Now we could start cancelling down. I quite like doing it like that. Or obviously you've got your calculator. But just to show you, you can kind of do some of this manually, cancelling down there. So you're actually left with 3003 divided by 4, 6, 20. And again, you've got your calculator. It's not necessarily a very good number. You end up with 0.65, sorry. Now, that isn't in standard form because this number is not bigger than 1 or bigger. So you need to then move the decimal this way so that it should be, oh, actually it doesn't want it in standard form, sorry, my bad. It actually wants it in pounds. So it's given it to you. It has actually worked out in, because I changed this back to pounds, it's given it in pounds, which is obviously 65 pence in there. So in fact, sorry, it's not standard form. They want it in the value. Okay. All right. Hopefully that's quite clear. But you could have changed this into standard form and that and done it like that, but I just decided to keep it as ordinary numbers and cancel down or use my calculator. Okay. Next question. Becky buys a new car for $25,000. The value of the car will depreciate by 20% at the end of the first year, then 12% every year after. Work out the value of 3 years. So to depreciate 2, 3, we start with 100% of the value and we're taking away 20% of the value. So we actually want 80% for the first year of the 80% of the original cost. So to do that, we need to times it by 0.8, and that will get what it's worth after the first year. Because it changes, I need to do it separately. Can't do it all in. It's not as easy to do it all in one go. You can, but I like to structure it a bit different. So at the end of the first year, it's worth £20,000. Then for the next 2 years, it goes down by 12%. So we're starting at 20,000. Then we can use compound depreciation. So that's when you times it by, because you're going to times it by a value, and it's going to be times at the same value twice because it's 2 years. It's the second year and the third year is the same. So again, if we're reducing it by 12%, we actually want 88% of the value as it is now. So you'd end up timesing it by 0.88 for the first year, and because you're doing the same thing for the second year, you can actually square that number because you're timesing it by 88% again, reducing it, sorry, by 12% again. And you should end up with a value 15488, and that is your, it doesn't say to round it or anything like that, it's money. So, and that is your final answer. So you have to, because these are different, you have to do, it's easier to do it in sort of separately. There's 2 years with 12%. You could have just times it by 0.88, got the answer, and then times it by 0.88 again. I've just skipped it because it was the same for 2 years. Okay. All right. So the next question, question number 6. We're heading now into more like grade 5 kind of questions. So as much as the grading doesn't really matter, you need to get the points, the grades, the points and the marks from somewhere. It's kind of nice to know roughly where these things sit. So yeah, grade 6, 7 going into sort of grade 5, I would say. All right, the diagram shows a shape made from a trapezium. So we've got a trapezium here, and it's got a semicircle on top, and the diameter of this semicircle is 8, which is obviously the top of the trapezium. So the height of the trapezium is 5. Work out the length of AB. So it's quite nice to know what we're actually doing here. AB. Give your answer correct. So we know this shape has an area of 64. Now, what the best way to do this is to think, well, I know it's 64. So what is my formula to get to 64? Okay, so the area of a circle is pi r squared. And then I'd be halving it, won't I? Because that's a semicircle. So that's my semicircle. Just going to do them separately up here for a second. Trapezium is A plus B. So that's the 2 parallel sides. Let's be that one plus that one. Divided by 2. And then times it by the height. And that is my trapezium. Now, if you add these two together in this case, you will get 64. So let's just set this out first of all. So pi r, radius, remember this is diameter it's given you here, so the radius will be 4 times 4 squared divided by 2 plus, the area is always you're adding the compound shape, you're adding the bits and pieces together, plus a, which one of the sides is actually 8, plus, we're going to call that b, call this b, divided by 2 times 5. And we know that's going to equal, where are we, 64. Okay, so there's lots of ways around. There's lots of ways around you can do this. I would just do it a step at a time. So pi times 16 divided 2 is actually going to be, because this 16, if you divide it by, if you you're timesing it by this and dividing it by 2, so you can actually just halve across here. So 16 divided 2 is 8. So that's going to be 8 pi. So whatever this is, so 16 times pi, actually halved in that, so it's actually 8 pi. Plus, now this whole thing here is going to be times by 5 and divided by 2. So if you times by 5, 240 plus 5b divided by 2 equals 64. Okay, and then let's simplify this a little bit here. We may have been able to do the division, but let's just keep as we're doing at the moment. So 8 pi plus, halving both these things, 20 plus 5 over 2b equals 64. Okay, so now what we can do, because we want b on its own really, we actually want the value of b here. So we can get rid of, these are actual numbers, 18 times pi is a number. We use the symbol, but it's actually 3.14, etc. So we can minus these from 64 to find, and leave this behind. So 64 minus 20 minus 8 pi equals 5 over 2b. And then let's just work that out. So 64, that's going to be 44 minus 8 pi, 5 over 2b, or 2.5b. I want to do this all in one calculator, so I just don't want to work out the pi part yet. So then you'll be doing 44 minus divided by, I'm going to just change this to 2.5, just so there's not two fractions going on here. So obviously 5 divided 2 is 2.5, so I've divided both sides by 2.5. And if I put them on my calculator, so 44 minus 8 pi, and then I end up with 18.867 for the top part, and if I divide that by 2.5, I end up with 7.5469. Enough space here, sorry. 7.546903. It wants it to do it to one decimal place, so I'll just change it to 7.5. Okay, so it's one decimal place after the, one number after the decimal, rounded here. Okay, so hopefully you followed that. They do use these quite a lot, where they give you the area and you have to figure out another part. That was a relatively complex one. You had to think of two different formulas, but hopefully you've understood. There's other ways you could have done that. You could have times the whole thing by 2 to get rid of this division. It still should give you this, well, it would give you the same answer done correctly. There are definitely more ways of doing it than that, but this is the way I kind of went with. Okay, so I hope that was quite clear. Just moving on to the next question. That would definitely be a grade 5 and above. Okay, on Monday, 4 bricklayers took 3 hours to lay a total of 4,200 bricks. On Tuesday, there are only 2 bricklayers. How many hours would it take 2 bricklayers to lay a total of 3,150? Okay, so if it took 4 bricklayers 3 hours, you can kind of think, well, if it took 4 bricklayers 3 hours to do this, how long will it take just 1? Okay, so how we do that is we would times it, because it's an inverse proportion. So as you get less bricklayers, the longer it will take. So if I basically, you would times 4 by 3, and if you're doing it on your own, it would take 12 hours to lay 4,200 bricks. So, and then you kind of think, well, how many can they lay in 1 hour? Let's say, for example, so 12 hours, they can lay 4,200. So if you do 4,200 divided by 12, so this is just for one person, it would take, they could do, so each bricklayer can lay 350 bricks per hour. Okay, now, okay, so 350 bricks per hour per one person. Now we've got 2 people on the next day, so for 2 people in 1 hour they can lay 700 bricks. 350 times 2 people, because you're obviously going to be able to do double the amount of things. So then it says how many hours would it take 2 bricklayers to lay a total of 3,150. Well, all you then need to do is go, well, I've got 3,150 and I know they can do 700 in 1 hour for 2 people. I would just share that 3,150 divided by, and it would come up to 4.5. So that would be 4.5 hours, basically. Because it's a decimal here, you need to convert it to how many hours. So that's 4.5 hours. Okay. Actually, either way would work. You could do 4.5 or 4.5 there. Hopefully that was clear. There's other ways you could think about doing that. But if you think about 4 bricklayers, took 3 hours to lay this, how long will it just take one? So it would take 12 hours to lay the same amount, because obviously it's going to be 4 times as slow. And then when you figured that out, so in 1 hour, I've divided it by 12 to get 1 hour's work out of 350. 2 people would therefore be double that, and then you're sharing the 150 with them. How many they were doing in 1 hour to get 4.5. Okay, so that's a ratio question. It's the inverse ratio, so the more you get of one thing, the less of something else. That's inverse ratio, inverse proportion. Okay, Simon invested an amount of money in a savings account, 0.5% per annum, compound interest. This is coming up again, this compound. At the end of 3 years, the amount of money in the savings account was here. Work out how much Simon invested. So we haven't got what the initial investment was. Normally, you have the initial amount, you times it by 1 plus the increase, and it will come out with the final amount in your bank. We've actually got it the other way around. We've actually got what it was at the end of the year. Sorry, 3 years. And sorry, to the power of 3 if it was 3 years. And so that's what it comes out as. The initial amount we don't know. Let's call it S for Simon. Times it by something. Times it by, well, it's a 0.5%. So if you start with 100%, you add 0.5%, you get 100.5%. Then this part here needs to be in a decimal amount. So we would divide this by 100 to get our decimal multiplier. And then it's for 3 years. Okay, now because you don't have this part here, but you know this and you know this, you have to rearrange it so that S, or your original amount, your initial amount, is the subject. So what you have to do, this is a multiplication. The inverse of multiplication is division. So S equals 12,180.90 divided by, and then to the power of 3. I've just divided both sides by this 1.005 to the power of 3. And then you can just pop that in your calculator. So 12,180, 12,180.9 divided by 1.005 cubed. And you should end up with, mine's come up with 11,999.999. Okay, so really, I would if you round this to pennies, if you like, because if you keep rounding, this will actually end up with 12,000. Because obviously to round this to 2 decimal places, which money should be, you then have to go, well, that goes to 0, and then pushes another one there, which goes to there, and then you end up rounding it up like that. Hopefully you can kind of see that. That's some rounding there. So he must have had 12,000 initially. He's added 0.5% for 3 years. Compound interest is how you do with compound interest, because you are gaining interest off your interest. And it is a formula you need to just sort of remember on that. Okay, there's 3 marks involved for that. So hopefully that is quite straightforward. Okay, next question, question number 9. Okay, so PR, so P to R and P to S are 2 sides of a square. P to S and P to T are two sides of a regular pentagon. So let's just pretend that's a square. Let's put that in there. And this is a pentagon. Okay. So PR and PT are two sides. PR and PT are two sides with n sides. Oh right, okay. So there's something going on here. We don't know how many this is. Blah blah blah, whatever. Okay, work out the value of n. So this and this are going to be the same. Okay, so PR and P are two sides of a square. So what we know about that is that if it's a square, internal would be 90. Now, if it's a pentagon, it's 5 sides. What you have to kind of remember, you can think of it, I like to break it up into triangles. It's always 1 less than, 2 less than, sorry. So you get the number of sides minus 2, and then you times it by 180. And that is because you can make up the shape of a pentagon with 3 triangles. It's always 2 sides less. So then the total angles in a pentagon would be 5 minus 2 times 180 equals 3 times 180. Which if you do that on your calculator, 540. But because that's the total, that's not each one. Total, so you can then divide it by 5 because each one is going to be the same. Divide it by 5 was 108. So you know that this angle here is 108. Put one, I'm going to put 90 here as well, that colour. So then this angle here has to be, because it's around a point, has to be 360 minus 90 minus 108. So let's just come in here. So 360 minus 90 minus 108, which gives us oops, I'm making an error there. 360 minus 90 minus 108, 162 degrees. So this one here has to be 162. Now we have to think about what shape has 162 as their internal, which sort of regular polygon has the 162. And the way I think it's best to do this is think of it as, think of the external angle, because this 162, if you think of the external here, it's always the internal plus external is always 180. It's a sort of straight line, a bit of a wibbly straight line. But if you think about 180 minus 162 equals 18 degrees. So this particular pentagon, their external angle is 18. Now, the exterior angles on any regular pentagon, the addition of them, if you add all of them up, always add up to 360. And I'm just going to use this as an example. This is what a lot of people forget. So if you think of this here, we know that was 108. The difference between that and the external will be 180 minus 108, that's 72. And we know there are 5 of those each, because it's always the same amount. And 72 times 5 will get you 360. And it's the same for a square. Obviously that's 90, so therefore it's 90. And there's 4 of them, 90 times 4. So however many, it's going to always be, for the amount of sides times the exterior will always be 360. So if you know that, and you know that 360 divide by 18 must give you the number of sides, because it's kind of the opposite way round. You're kind of saying, well, if 18's if I do 18 times my number of sides, I get 360. Therefore, 360 divided 18 gets my number of sides. Okay, so I do 360 and I divide it by 18. I will end up with 20. Okay, you can check that on your calculator, but that should be hopefully right. Yes, so my value of n, which is my number of sides, with n sides, so this one must have, I know I've drawn it definitely not with 20 sides, but this one must have 20 sides because its external angle is 18, and 18 times 20 gets me 360. So I hope you've seen that. You can brush up on that with, it's called interior, exterior angles of polygons. And it's just formulas to remember, and knowing that you can do either or both of them. You could find out interior by working out the exterior as well. For example, if I'd have done 360 divided by 5, I would have found out my exterior angle of this one, and therefore could have found my interior. So they're all interconnected. Okay. All right, next question. Where are we up to? Question number 10. Simultaneous equations. Now, to do simultaneous equations, you need to have either the x or y values, or whatever letter you have, one of them has to be the same. Now here, 2 and 7 aren't the same, 3 and 2 aren't the same, and it doesn't matter about the plus and minus to start with. So if they're not, you have to make it so that they are. Now on this one, I can't times 2 to get to 7 with anything, because 7 isn't even. I can't times 2 to get to 3 either. So I can't get them to these without doing two multiplications. So what I have to do, I'm going to call that equation number 1 and equation number 2. I'm going to times this one by 7, and I'm going to times this one by 2. Now what that does, I get a new equation number 3, and I end up with 14x. Remember, you have to if you're times an equation by something, every single bit of it needs to be times by that, otherwise it doesn't stay equivalent. So 14x, 3 times 7 equals 42. And then the next one I'm timesing equation number 4, times this by 2. So you can see now I've got x values are the same. Minus 2 times 2 is minus 4. And then 1 times 2 is 2. So I've now got two equations, and although there's bits different, these are the same. So what I can do is take one away from the other. They're both positive, so I have to use minus. So 14x take away 14x, 0. And that's what we have to have. We have to have a 0. 21 minus minus 4 actually is a positive, because we are minusing across the whole thing. You have to be really, really careful on those. So 21 minus minus 4 gets us positive 25y. And then 42 minus 2, 40. So y must equals 40 over 25. And then you can change it if you want to 1 and 15 over 25, 1 and 3/5. So I've got a y value now, 1 and 3/5. Now I need to find my x value. To find my x value, I use this y value. Now I can plug this in or substitute into any of these four. I'm just looking what's going to be my best one. I'm going to choose this first one here. So 2x plus 3 times 1 and 3/5 equals 6. So 2x plus 3 times this. I might do a little side note down here actually. So 3, I'm timesing it by 1 and 3/5. I'm going to change it back to my 40 over 25. And you times in fractions. It has to be, it can't be mixed numbers. So 120 over 25 is 4. And then you end up with 20 over 25, which is 4/5. And then 2x equals 6 minus 4 and 4/5. I mean, you've got your calculator for this. You could actually just use a calculator. So 6 minus 4 and 4/5 is 1 and 1/5. And then x must equal half of 1 and 1/5. I'll just use my calculator, it's easy, isn't it? So 1 and 1/5 is 6 over 5. 6 over 5 divide 2, and I get 3/5. So hopefully you can see what's happened there. It doesn't matter what format. I could have just put it in top heavy format for y, but I've just kept it on here. And if you have the time, maybe go back and check that these two plug in to here. Otherwise, yeah, that's it. That's simultaneous. That's actually not an easy one because there is elements of fractions, etc. But the reason they put these in there is to get you to test you on fractions, adding, subtracting, timesing. But you've got your calculator, so hopefully you've managed to, that takes some of the work away. Okay, that's question 10. Okay, so question 11. Here is a table. It's incomplete, and you've got partial table and partial box plot. Hopefully you've seen these box plots before, sometimes called box and whisker. So what you have to do is basically fill out the table. So the least number is shown by this line here. The first line is the least number. Be careful on the scale. You've got every sort of 5 blocks you can see is going to be 50. So then the first 2 blocks will be 20. So our least number will be 20. The lower quartile is the next line you come to, which is the end of the first quarter. And again, look down, make sure you're being careful. It's 150, 160, 170. So the lower quarter will be 170. And the median is going to be the next line you come to. So that's dead on the 200. And now you need to complete it. It's giving you the upper quarter at 280. So you grab your ruler. Oh, there we go. Grab your ruler and mark where 280 is. So it is about there. So that's your upper quartile. If you get this here and you join it up, the box in the middle basically is the the box in the middle is basically the middle 50% of the data. Okay, so you end up with the lower and upper quartile either side and the median somewhere in between. Obviously it's not always in the middle. Here it's not in the middle, it's off to one side. And then, so it's 280. And the greatest number is 405. So again, get as best you can, get to 405. And then like the least number, it will just be a little line. And it's kind of in the middle of these two, isn't it? They do sort of allow for a little bit of, it's not easy to do on the computer screen actually. But it should be just out after, and then line it up with the other line to join it. So box and whisker. So you can see what's used to be called. Well, it used to be. It is also called box and whisker. The box in the middle, and they've got these 2 whiskers that come out. So that's the least, the greatest, the lower quartile, the upper quartile, and then the median is in the middle of there. And each sort of section represents 25% of the data. So sometimes it's smaller, where the data is more contained, more consistent maybe, and here's 25. So each of those sort of sections separate the data in 25% increments. So it's just saying to use the information in the table to plot the box plot and the table as well. And for that, to start that question, that is it. It looks like there's more over the page. So let's go over the page and see what's coming up next. Okay, so the box plot below gives us information on the number of lorries using the bridge each day last February. Compare the distribution to the number of lorries used in the bridge last January and the distribution of the number of lorries used in the bridge last February. Okay, so the box plot you had before and this box plot here, you've got, it's 2 marks. So you need to talk about 2 things about these 2 pieces of data. Let's go back to the other one, and I'm going to try and snip this information. I don't know if this is going to work too well. I don't know if you'll be able to see. But it's really useful. If you have it in front of you, it's much easier. I'm just going to try and put it in front of me now so I can see when I move over the page. Unfortunately, I can't do 2 pages in one on this. Okay, so if I look at the data side by side, I can see that, well, in February, the median has gone from 200 now up to 250. So it's increased by, a fair amount there. The lowest amount has gone up from 20 to up to over 100. The highest amount is gone down. So it's strange. It's kind of it's a lot less spread out. You can see straight away the range is really, really different. So that's the first thing I'd write about, the range. Okay, the range for Feb is, what is that, 370 minus 130. 370 minus 130. So 370 minus 130. That's the range of all of the data. So it's going to be 240. And if you look at January, the range of the data is 405 minus 20, which is the least. So the range is 393 for January. So that's it's not picking that up. So the range it's not going to pick this up now. Sorry, I'm just going to get rid of that for a second. Alright, sorry. So the range of data, range in Feb was 100. Sorry, this is the problem with doing it live sometimes. It's absolutely okay. 370 minus is 240. And in Jan is it was 405 minus 20, it's 385. Okay, so it's quite a big difference. Therefore, the lorry using the bridge were more consistent in Feb. The data is basically nowhere near as spread out, so therefore more consistent, more compact. Then you can say about the median from the January data. So in Jan, the median was 200, Feb 250, therefore on average more in Feb. So I've said two things and I've said why. So I've given two pieces of information. The range, because I just noticed there's such a big difference, I thought the range is definitely worth mentioning. And if you talk about the range or interquartile range, it's always use the word consistent. Consistency with daily, obviously some days is loads less than others, probably because if you think about it logically, in January you've got probably not as much going on with regards to lorries moving around, because of maybe, I don't know, it's just not a very good month. Maybe people are still on holiday from Christmas and etc. So maybe that's why it's maybe not as consistent. And February just maybe goes into more of a normal sort of month, so the data is more consistent. So that's probably why. And then if you think no one's really moving around on the 1st of first of Jan, I would probably imagine that 20 date, the minimum in January, is probably that is really early Jan. But yeah, that's kind of the reason why. You don't need to write about that, obviously. It's just comparisons, saying that in Feb it's more consistent than Jan. And then I've just picked out the median, the difference in median. And if it's higher median, they're not obviously all bigger, but on average in February there are more lorries travelling over the bridge. So just on average, because median is a type of average, we can use that for that. Okay, so I would probably pick two things, 2 marks. 1 mark for a type of median and why, and then another mark for a type of range and why, on these kinds of questions. Okay, so let's head over to the next question. Sorry about that confusion with the slides, but so we have a cuboid and there are lines all through it. Now straight away 3D trigonometry just screams at me, because I know as soon as you see diagonals going through, and you can see there's a right angle there's a right angle at the back, it's going to be some form of trigonometry, Pythagoras maybe. So these are great to get practiced on and really understand where you are. And you can draw on these diagrams they give you. You can draw on them. Make sure you don't draw on them so much you can't see behind them. So maybe use a highlighter. But it is really important that you draw on them and understand where these lines are coming from and to. Spatial awareness is very important. And this line here goes across the back panel of the cuboid, so it's flat to the back, and this one's going straight through the whole shape. There's a sliced plane there. Okay, so work out angle EDH, so EDH. So the angle that we're talking about is on the flat of the floor, and it's that one, is 64 degrees. A, C, and then D. So if we look at this big triangle flat at the back this time, ACD is going to be here, and that's 28. Okay, EH is 15, that's written already for you. Work out the size of the angle AHD. AHD. So we want this one here. So we have a lot to go on here. So AHD, so we want this angle here. Now, we don't actually have any information about this triangle here, but we can get some. And we need 2 triangles to do that. Now the one flat across the back, I'm just going to draw the picture for you, is 28 here, and then 15 along here, because that EH is going to be the same as the DC. So you already have a bottom base and then the angle here. Now the angle that goes, this triangle that goes through here, the only thing that shares with this one is the height, and we can find that height because it's the same height as this one here. Okay, that's AD. It's the same height whether it goes flat to the back or whether it goes through the triangle. So how we do that, we look at this angle and we need the opposite angle, opposite side, sorry, and we've got the adjacent. Now if we think of SOHCAHTOA, opposite and adjacent, we're talking tan. So then we write tan, the angle's 28, TOA looks a bit like this, so that, or you can think of it like this, where tan is here and O over A. So we know we need the O, so we're going to, if we need the O, it's tan times the adjacent. So tan 28 times the adjacent, which is 15, equals the opposite. And you can also think of it like tan 28 equals opposite over adjacent, and then obviously therefore you times both sides by A to get the opposite. I've just kind of jumped. I like using these triangles because I can see exactly, I don't even need to rearrange it. I can just look straight at these triangles and go, to get O, I go tan times A, the adjacent. So if I do that on my calculator now, so just if you tap in tan 28, opens a bracket, so then make sure you close that bracket, times 15, and you end up with 7.9756 blah blah blah. Now that gives us this length. The height over here, 7.9. I'm going to round it to 2 decimal places, 7.98. Okay, and that's the height of that triangle. Now we still have only got this middle section one. We've only got the height. We don't have anything else, and we need something else. To get that angle, we need either this, which we can't find yet, but we can get this one that lays flat on the floor. We've got another triangle. That is a right angle. It's off at, it doesn't look like a right angle because it's sort of off at the side here, but that will always be a right angle, these corners. We don't know the height, but we know this is 64, and we know this is 15. And what we actually need to know is the hypotenuse here, D to H, because that will be the bottom base of the one we need. So we need the hypotenuse, and we've got the opposite. So for our formula, sorry, our SOHCAHTOA, looking at SOHCAHTOA, which one we need, we've got O and H, we need O and H sine, O and H. Okay, so let's move that away. So sine triangle looks a bit like this. Sine, O over H, O over H. Now we've got the O, we haven't got the H. So we need this one, so we have to do the opposite divided by sine, in this case 64, and the opposite is 15, divided sine 64. Okay, use these triangles, remember which way around they go. Often they won't work. If you've done it wrong, they don't work because hypotenuse has to be bigger than the opposite and adjacent, so sometimes they don't work. If they don't work, maybe you've times it instead of dividing it. So just make sure, if it does come up weird, just go back and look at these, remember these triangles. Alright, so we've got a hypotenuse, this one, of 16.689. So that gives us this part here, 16.69. And now we can now find the angle that we need. I'm just in a slightly different colour, orange. Now the one that slices along the middle, we want the angle here. We've got the height, that's 7.98. And now we've got the base, which is actually the hypotenuse to the other one. Just rounded them to 2 decimal places. That's fine. They'll always allow for some rounding here and there. So here we've got, this time we're looking for the angle. Remember that when you're looking for the angle, it's to the -1. Okay, so I've got my triangle here. I've got opposite and adjacent, so that's tan again. Opposite over adjacent, and now when it's angles, all you need to do, I find angles easier. Tan's the -1, opposite 7.98 divided by 16.69, and all in one swoop you get your answer. And the answer to that one is 25. I'm going to put it straight down here. It wants to one decimal place. I get 25.5538, so it's 25.6. Looking at the mark scheme, they do allow for some differences here, because along the way you've got lots of things you could have rounded. I would always do at least 2 decimal places, because otherwise it might get really out and you might then fall outside of the rounding areas. Always do at least 2 decimal places, but don't do 5 or 6. You'll end up overcomplicated. You don't need to. Yes, that was that question. That's quite tough. There's lots of steps, but that's 3D trigonometry. I would suggest if you got lost in there, I would practice and practice trigonometry until you can't literally practice anymore, and then start looking at 3D trigonometry, because it's the same thing. It's just built up. But if you understand trigonometry and how it works, and remember these triangles step by step, it gets much easier, and you've got much more chance if you know trigonometry inside and out and understand when there's angles involved. You have to use this SOHCAHTOA kind of triangle stuff. So that is definitely, again, if you got lost, just go back over trigonometry before starting to confuse yourself with the 3D stuff. Okay, so that was question number 12. Okay, question 13. 6 to the power minus 2 to the power of w equals 6 to 8. Now, this you just need to know the index rule that you're timesing over. So what you're saying is minus 2 times w equals 8. So then w equals 8 divided minus 2, which gives us minus 4. So if w is minus 4 times minus 2 gives us positive 8. And that's that one. It's just 1 mark. AR squared ATQ to be written from AU. Okay, so if AU equals AR squared over AT cubed, we're kind of going to get rid of the A's. We can leave it as form of U. So U equals, we're basically bringing down the indices. And when you times it over like here, remember we're timesing them, so it's actually going to be 2r, and then 3 times t is 3t, and that's actually it, because you just want it in terms of, so it's u equals 2r over 3t. Hopefully you can sort of see where that's come from, but it's just multiplying that out. You can, because it's saying that you're just talking about the indices, you're taking out the base number of a in that one. So a bit strange, but that's that question. Okay, given that n to the power 2/3 is 8 and n is greater than 0, work out the value of n. So n is 2/3 equals 8. Now remember, when you do changing indices, so for example, if I to convert this to something, I want it to look, I'd do the cube root of n, because that's the denominator, and then I'll square it. So I'm saying that equals 8, and then I can unpick it. So I'll do the square first. So the opposite of the square is a square root. So then you'd end up with square root of cube 3n is the same as square of 8. Then the opposite of the cube root would be the cube. So n would equal 8, root 8 cubed. Now, if we're going to cube root 8, what we'd actually end up with is root 8 times root 8 times root 8. Now, root 8 times root 8 is actually root 64, which is going to be 8, and then times root 8 again, which would be root 8. Okay, That's actually, looking at that's not in the simplest form, because this 8 can go into another square number, which is 4. So we can unpick that a little bit more. 8 times root 4 times root 2, because root 4 times root 2 is 8, but root 4 is a square number, which is 2. So 8 times 2 times root 2 gives us 16 root 2. And that's in its simplest format. I'm not sure if the mark scheme would have allowed for this, because you've kind of done most of the work. That's just simplifying, really, to make it into the simplest form. But that's a good practice to just spot. If you see a number in a root which has a square number that goes into it, like 4, 4 is the most important one to remember, then you can simplify further. Okay, next question. Question number 14. There are some flowers in a shop. Each flower is either red or yellow. Each flower is either tulip or a rose. For these flowers, number of tulips to the number of roses, 6, 5. Tulips to yellows. Work out the proportion of flowers that are red tulips. Okay, so tulips, and you can, the best thing to do is proportion wise is think about fractions. So the number of tulips as a proportion, as a fraction, is 6 out of 11, and the number of red flowers, flowers altogether, equals 3 out of, obviously you're adding these up, 3 out of 7. So what you want, the red, a proportion of the flowers that are red tulips, so it'd be flowers that are red and that are tulips, you would do 6 out of 11 times 3 out of 7, which can give you 18 out of 77. So 18 out of 77 are red tulips. You can work out all the others if you wanted. So 5 out of 11 would be red roses, and then you can work out the fraction of yellow roses, yellow tulips, like that. So really, this is easy to overcomplicate. Don't spend ages on these. It's 3 marks. Just think about it as a proportion. If it talks about proportion or as a percentage, turn it into fraction of how much are one or the other. Okay, so that's what I can say a tip, and I've seen quite a few of these ones, and they do end up, you are looking at times in the fractions. If you want a fraction, it's like you're doing a fraction of an amount, really. Okay, so that's that for question 14. Getting into probably more like grade 6, 6, 7 now, really. So question 15, Alison has some shapes, 14 red cubes, 10 red spheres, 12 black cubes, 8 black spheres. Alison is going to select 2 of these shapes. One can be red, one can be black, one can be cube, one can be sphere. How many ways can Alison select 2 shapes? Okay, so what can we select? First of all, we can select the red cube and then the black sphere. You can't have another red and you can't have another cube, okay? Or you can do the red sphere and then the black cube. And then you can kind of do the opposite way round. So you can do black sphere, red cube, black cube, red sphere. So there's 4 things we can do. Let's see now how many ways you can do it. So red cube times black sphere, so 14 times 8. Okay, that's how many, so it's 112. And then red sphere times black cube, red sphere, there are 10 red spheres times black cube, 12, 120. So we say 10 times 12. and then it's going to be the same the other way round. Oh, I actually don't think you need to double it, because how many ways can Alison select the two shapes? I think that because you're ending up with the same thing, I don't think you need to worry about that. So in total, 232 ways of selecting the two things, because essentially it's not saying probability. We're not talking about probability, it's just how many ways, and actually you're going to get the same answer whether you take the black out first, it doesn't matter. So there are 232 ways of selecting those things. Okay, so you really have to read that question a few times maybe to figure out what they're actually asking. Okay, next question. Question number 16. The graph y equals x squared is reflected in the line with the equation y equals x, give the curve C. Sketch a graph. Okay, now x squared graph, you should already know that it goes through the axis here and it kind of curves down and up like that, a bit like a big U. Okay, so it is going to be a sketch. It's a bit wobbly on my side, but okay, so that is y equals x squared. Sketch the graph y equals x squared and the curve C. So it has been reflected in the line with equation y equals x. Now y equals x is basically means when y is a number, x is the same number. Y equals x. Okay, so how that looks, it will just cut the axis like that. So when y is negative, x is negative. When x is it's the same, basically the same number. And what you might, I'll probably have to rub that out. Yeah, I'm just going to rub that. I'm just going to redo that one again. Slightly better shape. Okay, so it comes down, round. It's going to do a bit like that. Okay, it's a little bit better maybe. Okay, so sketch the graph. So it's been reflected in this line. So what that means is everything that's over one side of the line will now become this side of the line. So, and it'll be a reflection. I'm going to draw the reflection in a different colour. Let's do it in green. So my reflection curve C, if you think of this as a mirror line, it will go, that will look a bit like that, maybe. And that one will go like that and like that. Okay, mine isn't perfect, but if you think about this as a mirror, this blue line here is here, this blue line here is here, this is kind of like here. So you can see it's a curve. Hopefully you can kind of make that out. I'm sure it's one you can do a bit better. But I think as long as you've got the shapes and the reflections of what you've done, because it doesn't say how steep it's meant to be or anything, so they are a bit mindful of that. Clearly label the graph. Right, I'm going to label this curve C. And that's it. 3 marks for that. You'd probably get a mark for each thing. So you get a mark for the x squared, just drawing that. You get a mark for the y equals x line, and then you get a mark for the reflection, the decent reflection of that. Turn the page. That's what I would say with this. Turn the page so that this is straight, so you can kind of see the symmetry on that sort of question. There is more to this question, so let's just turn the page and see what's coming up. Okay, it's not particularly linked with this, so that's going to. Okay, so here are 7 graphs. There are some equations. Let's see which one is what. So 3 to the power x. Now with I normally like to think of all of these as, let's just wipe out the ones that are really obvious. So for example, I think tan graph is quite obvious on there, because tan as D is quite an obvious one really. So that's what the tan graph should look like. It's kind of repeats every 90, so it's quite an obvious one. Then you've got a cube, although there's 2 that could be the cube. So you've got this one here, this is a cube, and this one here. Now, the way I would differentiate these is that it's a cube, but it's still, this 2 here, this constant term, is where it goes through the y-axis, sorry, because when x is 0, y is going to be 2. So therefore, it has to be this one, because it goes over it at, that looks like it goes over at -2, that's +2. Okay, so I think that one is relatively straightforward. Maybe. 3 over x. Now that is an exponential, which means that when x is 0, it doesn't exist. So there's an asymptote, and so therefore it has to be a split graph. Oh, sorry, that should be right across the middle there. And so that should be graph E. And now we have one more. Now that's where it looks like they've kind of separated these out a little bit actually. We know it's not going to be a straight line, because it's an e to the power x, so it's not going to be one of those. Now, anything to the power of, what is important to understand is as powers go up, it goes up really, really quickly. So, for example, you know, if you're squaring something, it goes up quite gradually at first, and it goes up and up and up, and up really, really quickly. So, in that case, if you look at these two, they're quite similar. One's the negative of the other basically, but this one is the one that's going up positively, and therefore must be, this one is a positive number, so it must be going up in that direction. Okay, so it must be A, and it spells ADGE. Alright, so that's that question done. Just get familiar with them. This is really hard to practice, to be honest with you. You just have to have a good understanding of what they mean. And it kind of takes a lot of knowledge to know bits and pieces of this, you know, small question. But hopefully you do a few and you'll recognise some, and just cancel the ones that you can do. And then even if you don't know the last one, at least it's a bit of a guess. And you've kind of narrowed it down. But this is the cubic, it has 2 turns. All right, so next question. Question number 17. So the number of moose in Alaska at the start of the year is P, and they use P a lot because of population. The number of moose in Alaska at the start of the following year is given by, basically, n+1 is going to be, and you put Pn in. So the population goes in, you minus something, in this case, a constant, times it by 1.04, and it gives you the population of the next year. And it keeps going up or down, depending on the equation. So the number of moose in Alaska at the start of the year is defined as P to the N. At the beginning of 2015, there were 200,000 moose in Alaska. At the beginning of 2016, there was 200,720. Work out how many moose in Alaska at the beginning of 2017. Okay, so this is quite challenging in a way. You kind of know one and the other. We've got to find this G first of all, because we don't know G. It's got G as a constant. Normally you're given the formula, but this time you're given 2 pieces of information to work out G. Okay, but it's still a formula thing. So the second year we're talking about is defined by the first year going in and then coming out as the second year. So we'll plug them in. So in 2016, 200,720 equals 1.04. Probability Pn, which is the first year going in, minus G. Okay, and now we're going to solve this to figure out G, which is our constant, so we can then pop in the answer from 16 to find the answer to 17. So we'll leave this bit as it is at the moment. So 1.04 times 200,000 gives us, because I'm expanding this bracket now, minus 1.04 G. I don't know what G is, so I can't times it by anything, but I know I can change it into 1.4 times that number. Okay, then when we've got this part here, I can take away this lump here. So 200, 720 minus 208,000 equals negative 10.04 G. Okay, so let's do that. So I've got 200,720 minus 208,000, and I end up with a minus. Probably should have taken it the other way, but it doesn't really matter as long as I'm careful with my negatives. Minus 1.04 G, and then because I know it's this times this, I'll do the division to counteract that. But yeah, of course you could have taken it the other way and then you would have ended up with a positive number. That would give me G. So divided by minus 1.04, and so G is 7,000. Nice round number. That gives me some confidence when it's a nice round number like that. It's not always the case, but okay, so now we've got off, we go back to our formula and say, well, my answer for 2017 has therefore got to be 1.04. The probability of the year before that, was 200,720 minus G. Now we've found out what G is now. And that's it. So we'll end up with so 200,720 minus 7,000, and then times that by 1.04 equals, and so in 2017 population is 201,468.8. And it's a population amount, it's a thing, so it needs to be a round number. 6, 8, oops. Okay. So really this one is an unusual kind of iteration question where you don't actually have the full formula. You need to use two pieces of information to find the full formula. And then and work it back from there. Just making sure the moose went up, and they did. So hopefully you followed that. But if not, maybe practice some iteration questions just to understand what's going on. Essentially, you put a number in from the year before, you use the formula to get the number out from the next year or whatever. Okay, hopefully that's okay. Okay, next question. We're heading into grade 7 for sure now. So, and that's at least really. Solve the inequality. Represent the number on the number line. Okay, this is a quadratic inequality. Now it's not an easy one because there's a number in front of the x squared. Now how I factorise mine and how we see, is it factorisable? Let's just check if it's factorisable. So I always do 2 times minus 3, so that gives us minus 6, and then in the middle is 1 because it's 1x. Then I'm finding, is there a number, two numbers, sorry, that I can times to get minus 6 and add to get 1? Well, yes, there is. I can times 3 by minus 2, and I get, timesing it gets minus 6, adding it gets 1, so that works. And then I put those two numbers over my number in front of the x squared, and then this stays the same, 3 over 2 is as simple as I can get it. This turns to minus 1 over, oops, just 1. Okay, and how we do that in the brackets, we end up with, so again, this is harder quadratic, so if you don't follow, it might be a good idea to look up some harder quadratics and practice these. They come up all the time. But what I've got here, I use this side for my first bracket. So the number underneath is the x value, the number on top is the number here. So 2x plus 3, and then 1x, or just x, minus 1. So that is me factorising is less than 1. Now, if you think of this on the graph, we're going to go through the axis on, so x is going to equal minus 3 over 2, and x is also going to equal 1. So x equals 1 is there, minus 3 over 2, or 1.5, minus 3 over 2. So my quadratic looks a little bit like that. And it also goes through minus 3 there. I only know that because it's looking here, although that's not relevant for this particular point. Now, what is important though, this is inequalities here. So this is saying this, I want to know all the values that are less than 0. Now less than 0 is under this line. So my graph under the line is all of this part here. So what I need to say is, well, if you think of this as a number line, my x values between minus 3 over 2 and 1 are under that line. So how I show that on my graph is, I come along here, I've got my inequality line here, and I want minus 1.5 to 1, so 1 is there, and minus 1.5 is about there, and then I end it with like a round circle, like that, and it's less than, so I'm leaving my circles empty because it's less than, it doesn't include the line itself, it's anything less than, so I always leave it as an empty circle. So that should be between, it's a little bit far actually, I should have been a bit closer to here. Anything between minus 1.5 and 1 is where my graph is under less than 0. If it was greater than, it would be all of these numbers above and you'd have a split thing, but it's actually less than. So that is inequalities, quadratic inequalities. So again, practice that. This is not easy, but there's quite a few skills. It is 4 marks though, so it's really worth practicing these quadratics. They come up so much, and you won't be sorry you've practiced these to death if you manage to practice loads. Inside and out really with those ones, I would suggest. Okay, so next question, question number 19. It's a vectors question. O to A is A, O to B is B, P is a point of AB such, AP to PB is 3 to 2. So break that down, that's 5 parts in total. So A to P is 3 lots of those parts, 3 out of 5, and P to B is 2 lots of 5. What I do first of all is figure out, well, what is B to A? So B to A, how I would do that, I would go via the vector. Remember, you can always go just via vectors. It'd be minus B plus A. Okay, so B to A. B to P would be 2/5 of that. And how you do this is just write it out, 2/5 of minus B plus A, and you can kind of rearrange this so that I've just expanded it out really. 2/5 of the same thing. Okay, so that's B to P, but I want to know what O to P is. O to P is OB plus BP. Now O to B is just B, isn't it? O to B. And B to P we've already worked out is this one here. So minus 2/5 B plus 2/5 A. So just simplifying that, B minus 2/5 B is going to be 3/5 B plus 2/5 A. And that's it. That's 3 marks. Normally they structure it out a little bit for vectors questions, but actually that wasn't too bad. Just remember what you know, and then write down on anything that you need to help you out on these vectors questions. They generally do put a bit of ratio in there as well. Okay, let's go to the next question. Question number 20. Show that f of fx equals x. So here you've got one function of f, and I want to put f inside f. So what I would do is for every x, I'm going to put in a function of f. So into f, I'm almost putting into f. So 1 minus, and then 1 minus x over 1 plus x over 1 plus 1 minus x over 1 plus x. Okay, so what I need to do is, if you're minusing a fraction here, you need to be able to have the denominators the same, so that equals 1 minus this. Well, I'm going to change the denominator to x plus 1 on here, so it ends up with 1 plus x over 1 plus x minus 1 minus x over 1 plus x over, and it's the same for the other side, so you're timesing up here. I'm just changing my 1 to something that is the same as a 1, just so the denominator is the same. This looks really complicated at the moment. It will get a bit easier looking. So you're minusing 1 from the other, so 1 minus 1 is 0. X minus minus x gets us 2x over 1 plus x, and then all over 1 plus 1 is 2, x plus minus x is 0, so then underneath is 2 over 1 plus x. Now this is a division. It's a division of a division, so division of a fraction I should say, sorry, 1 plus x. So if you're dividing by, so I'm dividing by 2 over 1 plus x. I can change it so I times. So I keep that the same, times that. This is going off the screen a little bit, isn't it? Maybe I've done too many steps here, but 2x times 1 is 2x, 2x times x, 2x squared plus 2x over 2 plus 2x. We've got lots of 2's going on here. And then that equals, if we cancel, we can factorise 2 out of there, so you end up with x squared plus x over 1 plus x. Now what is it saying? Show that equals x. It doesn't. Okay, so x times by x plus 1, factorising the x out, and then x plus 1 at the bottom. So I then have top and bottom cancelled out, so that equals x. Sorry. So that's that is quite a long question, longer than I thought actually when I started, obviously, not leaving that much space. Hopefully you kind of followed it. I did probably do more steps than I needed to, but that was kind of to show you really. So remembering that when you're doing f into f, you're literally putting the function of f, which is the whole thing, into wherever there is an x. That's why I put the whole thing in to the x values. To minus a fraction, you have to have the denominators the same, so I had to times this one top and bottom by 1 plus x, and the same underneath. Then you end up with a division, because you've got dividing fractions, so then you keep it, change it, flip it, and that gives you an answer here, which cancels down if you factorise out, and it does equal, if you don't think it equals x, if you get to this point and think, oh, it doesn't equal x, just think about factorising out. It might give you a bit of a clue. But yeah, I obviously stopped there because I was like, oh, but then I just realised that you just factorise out and you can simplify, cross simplify. Okay. Hence, write down f to the minus 1. So f to the minus 1 is the inverse of x. So with b, if the inverse of that would be x, the inverse would actually be the same. So you're putting it in, you're getting out, you're almost putting it in and getting it out the same. So therefore, 1 minus x over. Okay. It's only for 1 mark, that one. All right, next question. Okay, so this is question 21. It's the last question on the paper, and it is a challenging one. I'm not 100% sure. I've done this through. I think I've worked it out, but I'm confused a little bit with the wording. All right, so reading this through, we've got Kevin that takes a random counter from the bag, and then Lefton takes a random counter to the bag, and they put them back in. The probability that both counters are red or that both counters are yellow are 13 over 36. Probability that the first counter is red and the second counter is not red is a quarter. Seb takes a random counter from the bag. Work out the probability that Seb takes a yellow counter. Now, where I don't understand is when I work this through, I don't feel like I need the second bit of the information. So correct me if I'm wrong. If somebody's done this and think I'm getting this wrong, please say, because I'm not 100% sure about this one. So if you look at this, the probability that both counters are red or yellow is 13 over 36. Now, if you think of or, it's that or that happening. So it's red and red or yellow and yellow. Now, if we call red R, you're going to square it and you're going to add it to the square of Y, yellow. So that's the probability of R happening and the probability of Y happening. Now, because what they're out of, because if they've put the counters back in the bag, the denominator is going to be the same for the bottom. So if you look at this denominator 36, well, these have to, and therefore, be over 6, because 6 times 6 is 36. So these have to be over 6. So it's however many there are here, over 6. Sorry, over 36, but then R, the actual initial, because obviously there's two, if you think of a tree diagram, you're doing R, then R, the denominator of those two is going to be something over 6 times so something R over 6 times another R over 6. Now these R's have to be the same, and then I'm going to add it to a Y over 6 times another Y over 6, because that makes that 36 R squared over 36 plus Y squared over 36. It kind of has to be, the denominator has to be that, equals 13 over 36. And if we deduce from that, R squared plus Y squared has to equal 13, if you think of the denominators sort of equaling out. Now with this, you can figure out that slightly logically. I haven't done this in any way other than logically thinking. Red squared plus Y squared is 13. Well, two square numbers are going to 13 are 4 plus 9. And they're both square numbers. So R, so 3 squared plus 2 squared equals, oops, don't know where I've got 12 from, equals 13. So my pen's gone a bit funny. So therefore, R, I've seen what I've done. Okay, so R or Y equals 2 and R or Y equals 3. So they could be either way around. So you could have 3 out of 6 yellows or 2 out of 6 yellows. So we've actually got 2 pieces of information here. This is why we have to look at this section here. Okay, this is a difficult question actually. It's kind of getting your head around this a little bit. So probably that both counts are red. Probably the first counter is red and the second counter is not red is a quarter. So now we have to see what works out as true. Now, if we say, for example, that there are either 3 or 2 red. So let's say there are 2 red. 2 out of 6 times 3 out of 6 is our red, then yellow. So that satisfies red and then not red. That gives us 6 out of 36. And if we do, if we think that's that, a quarter minus 6 over 36 equals, I'm going to change this quarter to 9 over 36 minus 6 over 36 gives us 3 over 36. Now that would have to be the probability of red times blue. So if red was 2 over 6, could blue be something to equal 3 out of 36? Well, no, because 2 times, there isn't a number you can times by 2 to get 3. However, if I decided that the yellow was the 2 out of 6 and the red was a 3 out of 6, if I change the red here to 3 out of 6, if this is now red, it's 3 out of 6. Doesn't change this one obviously because I've just swapped them over. And I'm still taking that away. I still have 3 out of 36 to get my difference. Therefore blue, and you can times 3 times 1 gets you 3, and then that 36. So therefore there must be 3 red, 2 yellow, and 1 blue. Sorry, it's really messy, but the probability that Seb takes a yellow counter would be this 2 here. So 2 out, I'll put the answer up here, 2 out of 6 is our probability that he selects a yellow counter. So that's where you're kind of getting the information from. I originally thought, because I put it in, I thought, oh, it must be 1, but that's because I just so happened to pick the red being 3 out of 6. But actually, it could be either way around. So that's why you have to use the second piece of information to deduce that the yellow actually has to be the 2 and the red has to be the 3. Okay, because obviously this could be either way around. Alright, so I hope that explained that one. That's quite a difficult question, but as it's the last question on the paper, you would expect it to be quite challenging. And it was definitely quite challenging getting your head around that one. Okay, but if you found an easier way of doing that, please, or any of the questions, do not hesitate to write in the comments, and also please subscribe. I'm putting up papers and to help really, so that people can do the questions, see how you answer it, and a bit of discussion sometimes potentially if people are struggling with their revision for their GCSEs. Okay, thank you very much for listening.